Now we're going to look at the options in Simatic, how to connect to field equipment, sensors and actuators. And then we're going to look a little into Profinet 2, which is the field bus, the proprietary field bus that Siemens uses. Okay, then we have to jump down to this. How do we interface them? And there's a figure. We have a CPU. And what we have looked at so far is that we can have, this is just an example with analog input. For an analog input, so we can have the analog input in next to our CPU, let's say a central rack. And here we got a sensor, and we prefer 20 milliamps. We could have smart sensors, then we use Profinet to connect them directly to our CPU. And then what we can have too is we can take this I/O module, put it in a remote location, then we call it remote input output. We've got interface modules, communicate on Profinet of some type, and the connection is 20 milliamps as it would, as the I/O module would sit in the central rack itself. So of course, in modern plant, we have to distribute our I/O. There's not enough space in our cabinet to wire everything in central. It's expensive to use a lot of cable. Because plants, they're growing, they're getting bigger and bigger geographically, so they're kind of spreading out. Analog output is the same as smart actuator. Use communicated directly in remote I/O and use 40-20 milliamp if we have to interface it directly. And then we have digital input. So here we could have a smart digital input or output. Of course, we could have and use it connected to the network itself, but that's kind of expensive for true false. Do it directly. And we put it in the remote input output. And that will be the same with digital outputs. An actuator, digital actuator with that smart, I don't know. There's something called I/O link for things like that, where you the actuator and digital input and digital outputs are a little smarter. Yeah, and then Profinet. Yes. It's a little about a standard and what it is about. So this is on TCP/IP, but we have something called isochronous real mode 2. A time-sensitive network here is Profinet. So they have two profiles, three. You have normal communication and so on. So what we have here is non-real-time communication, whatever you have, configuration data or whatever you have. And then you have real-time communication. That's a little more time critical and use special frames and so on, TCP/IP. Yeah, and it's all it's made by Siemens, but there is an organization that's kind of, because they're trying to standardize on this. There's quite a few suppliers that can supply devices for Profinet, tend to be the same that supply devices for Profibus, which is then obsolete. It's now obsolete. You have real-time communication, and then we've got isochronous real-time communication, which is the fun part here, or the important part. So what you do here, it says a little about how this exchange is. How do you do it with the isochronous real-time frames mixed in with other frames and so on. But what they do is, this is collision avoidance. So what we have to do, we can't have collisions, so we need a switch, a device that can buffer information, and we need 4-wire connections down to the switch, so we can send and receive simultaneous, so we don't have to switch this for both hosts, and so on. But then the switch has to do something more. It has to be time sensitive. So these hosts, they need the size be synchronized, really nicely synchronized. And the switch itself is intelligent. So at certain intervals, they say, okay, here is an open tunnel for you. Every 250 microsecond, every millisecond, you can transmit your data. You can transmit data, have data exchange. And this one here, no matter what, I don't know what he is doing, but it's not that important. He has to wait. But of course, he needs to be able to transmit eventually the communication. So it's buffered, and when this stuff is done, he can transmit it, but then it's not deterministic, especially not isochronous real time. It's not that. Okay, so what we looked now about was how to interface, let's say, actuator sensors, instrumentation to a Simatic. We could have I/O modules in our central rack next to a CPU. We could have remote I/O, or we could use a field bus to communicate with smart equipment. Then we looked a little into Profinet itself. Very brief introduction, but there are the profiles. We got normal traffic, non-important traffic. Then we got real time, and for really harsh, time-sensitive information, we got isochronous real time. And this, the last methodology, is also going to be what you're going to find in what we call time-sensitive networks too. There's not a lot of ways to do this on an Ethernet, which is not deterministic. You need some special mechanism in your switches to implement deterministic communication.